Hey everybody, welcome back. Today 11.4, we're going to be talking about arcs and chords. We've talked about arcs before, but now we're going to get a couple more equations in here. Let's get started. We're going to be using properties of chords and circles today. First thing I want you to do is I want you to write this down, a couple more theorems to add to your pile of infinite theorems. You probably feel like that. Okay, so pause now and then I will explain. It says, in a circle, if a radius, or a diameter for that reason, is perpendicular to a chord, then it bisects the chord and its arc. Okay, so if you look at these two, it becomes a perpendicular bisector of, CD would become a perpendicular bisector of EF. Okay, but that also leads into the next theorem where it says in a circle the perpendicular bisector of a chord is a radius. Remember, a perpendicular bisector cuts it and you have four 90-degree angles, but then at the same time you have your congruent segments. So if you look at that top piece, E, and let's just call this middle one, this middle point, X. Okay, so EX would be equal to XF. Okay, and if you go backwards, that's the same thing. FX is equal to XE. Okay, because they are now the same. All right. And then that also leads to this bottom one. JK is a perpendicular bisector of GJ. Then JK is the diameter of circle A. All right? All right, so let's try a few. Please write this down and give it a shot to see using those theorems that we just wrote down. Give it a shot. All right. So if you look at SR, that's what we're looking for. We're looking for this chord right here. Okay, and what pieces of information do we know? Well, this 90-degree angle right here gives me a big piece. Okay, that informs me a lot. Because that is a perpendicular bisector, we know that PQ is going to be your diameter. That's a perpendicular bisector which cuts that chord right in half, which tells me that SN is congruent to NR. Okay, well, if SN is congruent to NR, then, because NR is 12, SN has to be 12. Okay, so because then we know SN is 12, we just add it because we're looking for SR. So SR is going to be equal to 24. All right, we just plug in what we know. Make sure you answer the question that it asks for. Awesome. Here's the next one. You're going to be finding NS and NP. Now, one thing I want you to know, that S is this middle point here. Okay, the 8 goes for RS, and the that 9 goes to MS, right here. So the 9 goes here, the 8 goes here. You are trying to find NS and NP. If you have any idea, I want you to give it a shot. All right, so when you look at this, okay, if I look at this, the very first thing I know for a fact is RM. I know RM, okay, and when you think about it, how does that really help us? I'll explain in just a second. Okay, I know RM, and RM is a radius, okay, and we know because RM, what would RM be? It's a radius, which is going to equal to 17, because 8 plus 9 is 17, okay. Then we know that we have this perpendicular bisector here, which tells me that NS is equal to SP. All right? It gives me another piece of information. But how in the world could I figure out NS? Well, if you're completely lost, here's a hint. What if I created looking at that, a 90 degree, or sorry, a right triangle. Now I have a right triangle. And we actually already know what Rn is. What do you think Rn would be? Rn is 17. And the reason why Rn is 17 is because it is a radius. All radius, remember that R is in the center, all radius are the exact same length. So Rm was 17, which means Rn is 17. Now, I created Rn, so now if I kind of just took this entire shape here, and I'm just going to kind of redraw it right out here so you can clearly see we have our 90 degree, we have R, S, not S, that's an 8, R, S, this is 8, this is 17. We're trying to find NS, right? Which is my X here. How do you think you could find NS? Pythagorean theorem. Remember we talked about that a while ago. We can't use trig, okay? I know you may be thinking we could use trig, but we can't yet because we don't know an angle measure. All right, not sure on an angle measure, so we can't use it. All right, so if I look at this, I'm going to use Pythagorean theorem. I now need to take x squared plus 8 squared is equal to 17 squared. Once I get 8 squared, I get 64. So I'm subtracting 64 from 289 because 289 is 17, so minus 64 here. And now x squared is going to equal 225. Find the square root, and x is going to equal to 15. All right, so now I have 15. Sweet! Am I done? No, I just found NS. NS is equal to 15. So x now is 15. Now, when looking at this triangle, I'm trying to find NS. NP. Well, if NS is half of NP, which we know because that radius RM is a perpendicular bisector, we know that we just double NS and we get NP, which is 30. Okay, so I used Pythagorean theorem to my advantage. Okay, I can create that that right triangle there, just kind of using the information that I know, which puts me in line and helps me out with setting up looking for that NS. So use the information that you know from past and present, okay, and then plugging that into this circle and solving. All right, awesome. So here's a couple more pieces of information that I want you to know. So you can pause now and please write these 3 things down. All right, so if you look at these, it says in a circle or congruent circle. So this is, if you look at, this is true for one circle, or it's true if you say that B is congruent to circle C. So this is true not only for one circle, but also if I say that these 2 circles are congruent, it also works for that. Okay, so congruent central angles have congruent chords. Okay, so if you look at this, if I know that angle BAC, okay, is congruent to angle EAD, okay, then my chords have to be congruent in between those 2 angles. Now chord, if I would say chord CD here, okay, is that going to be congruent to chord DE or chord BC? No, because it does not have the exact same angle measure. We need the angle measures to make sure that the chords are the same. Okay, now if you look at that, if you have the chords that are equal, then the arcs are equal. Okay, so again, if all of these are very, very connected to each other. So if I have the central angle, then the chords are going to be the same measure, which means if the chords are the same measure, then the arcs have to be the same measure. Or we could go backwards. If I say the arcs have congruent arcs, then they have the exact same central angle, which means they also have the exact same chords. So all of these are connected. Essentially, if you have one congruent pair of chords, one congruent pair of arcs, or one congruent pair of central angles, then the other two are congruent. Make sense? Well, I hope so. Okay, because we're going to have a couple problems here. So if I look at this, and this is something that I'm going to solve here, it says PT bisects angle RPS. Okay, we're going to be finding RT. Well, if we know that PT bisects RPS, then that bisector makes them congruent. Okay, well, when we have congruent central angles, then I have congruent chords, okay, which means 6x is equal to 20 minus 4x. Now I just do the algebra behind it. Add 4x to both sides. I now have 10x is equal to 20. Divide by 10. And x is equal to 2. Am I done? No, because I have to take that 2 and I have to plug it back into RT. Well, if RT is equal to 6 times x, which is x is going to be 2, okay, RT is equal to 12. Awesome. Okay, so make sure that you follow the directions. You're answering, once again, answering what they are asking for. Sweet! Are you ready to go? Moving on. Okay, now on this, what I want you to do is I want you to find x. So give this one a shot, see if you can find x here. Alright, so looking at this, finding x, what information do I know? Well, I know that my chords are congruent. If I have congruent chords, then I have congruent arcs, which tells me my central angles are congruent. So because those central angles are congruent, I now have 4x is equal to x plus 45, not 35, 45, 45. God, I love that show. Subtract x, not the show, the TV station. Subtract x, which then gives us 3x on this left side, 45, 45 on the right. We take 3, divide by 3, divide 45 by 3, and we get x is equal to 15, and I'm done. Now, why am I done? Well, the directions just say find x. Don't find the central angle, just find x. Alright, so I just answered the question. Sweet! Okay, so here's the last one of the day. Again, you'll notice that there's going to be algebra. This is algebra heavy today. Geometry concepts, algebra heavy. That's okay. Alright, what I want you to do is I want you to find WS, okay, but make sure that you solve correctly. Okay, so give this one a shot. Alright, so the pieces of information tells me that TV is congruent to WS. TV is congruent to WS, TV. Okay, and we're finding the measure of arc WS. Now, we're talking about this arc, remember, okay, not the large arc, because if it doesn't specify which way it goes, we can assume that it's that minor arc. Alright, so we now have TV is congruent to WS. What can we say then? Well, we can say 9n minus 11 is equal to 7n plus 11. Now we get into our algebra. Subtract 7n on both sides. 2n minus 11 is equal to 11. Add 11 on both sides. 2n is equal to 22. Divide by 2. And n is equal to 11. Okay? Are we done? No, we're not done. We have to take this n equals 11. We're trying to find arc WS. Here's arc WS. We plug that in, so I get 7 times 11 plus 11. That's 77 plus 11. And we get 88. What is the measure of 88? Or sorry, what is the measure of the arc? 88 degrees. Okay, don't forget your degree symbol. All right, any questions? I don't hear any. Moving on. R. Done for the day. We're done for the day. Okay, so all I want you to do is make sure that you have your notes written down correctly. They are organized. You drew the shapes that you were supposed to draw. You wrote all the theorems that you were supposed to write. And you will get your homework tomorrow. Have a wonderful day. Bye!